This is the Marble Machine X, and this is the mechanical rhythm machine of the Marble Machine X. The Marble Machine X has a kick drum, a snare drum, and a hi-hat. And this trio can play a normal beat. Right? And then maybe often, to make it sound professional in production, you add a shaker. This mechanical rhythm machine is the shaker of the Marble Machine X. So it's situated on the crankshaft and it has 4 different discs. One disc plays the first stroke of each bar. One disc plays the offbeat. One disc plays 16th. One disc plays triplet. And by levers I can control the volume and the envelope of each sound. And this will be mic'd, as always, by contact microphones. The rotation of the crankshaft is always in perfect timing with the music, and since there was this empty space in the base of the machine, I added this rhythm machine as an addition to the already existing kick drum, snare drum, hi-hat and cymbal. In the end of this video, I'm going to try for the first time if this rhythm machine can play tight music, and even more important, if I can sync it up to the timing of the marble drops. But before I can do that, I need to make the parts. In the first operation, I machined all the surfaces and I cut all the screw holes. This way I could use all these holes for hold downs. So I put a screw in every single hole, which ended up being a lot of screws, but the advantage is that I don't need any tabs, which means that after being cut on the CNC machine, the pieces are ready to be assembled without any further post-processing. So I checked the fit and it was spot on, so I could countersink these 3 holes in the first plywood disc. And the other plywood disc is getting some threaded insert. Here you can see how the set screws are going to be placed, and whenever I need a hole in the lateral direction from the plywood, I often machine 2 pieces of plywood like this and I put them together, and that creates that hole immediately off the CNC machine. Here I'm inserting the threaded insert for the set screws. These set screws need to clamp really tight on the shaft, so I'm not going to rely on plywood threads in this case. It's also the wrong grain direction for really strong plywood threads. So next in line was this adjusting disc. It needed some countersinks and some hammered inserts, and this is a trick I learned from watching Matthias Wandel. You can tap the hammered insert and then you can get 4 little marks where the points from the hammered insert wants to go into the plywood. If you pilot drill those 4 points, the hammered insert will go in perfectly without damaging the wood. So you see this threaded insert here sits really close to the edge. This is a good example of what good quality birch plywood can do, but normal plywood can't. It's only like 1-2 millimeters material here, and as you can see, the plywood accepts it. Kind of. These 5 screws will meet these 5 threaded inserts, like so. And through these holes comes these screws that will meet these 5 threaded inserts. Over-engineered? Yes. Beautiful? Yes. Does it work? Yes. Can we trust it on the world tour? Yes. Overkill? Yes. Beautiful? Yes. Does it make me happy? Yes. Can we trust it for the world tour? Yes. To be able to assemble the rhythm machine onto the Marble Machine X, I needed access to the crankshafts. I needed to remove some gears, I needed to decouple the flywheel flat belt, and I needed to remove the crank. And then I could slide the shaft over, and once I did that, I could start putting the plywood disc onto the shaft. Here I am lining up the 16th disc. They have only one configuration where they fit perfectly with each other. So I'm taking one of the beats from the 16th disc and lining it up with the first beat from the triplet disc. And once this half of the rhythm machine is assembled, I can clamp all these discs together using the 5 through bolts. And then I can start assemble the second half. So first the offbeat disc, and then some spacer discs in between, and last the whole note disc, or the 4 on the floor disc. You could say that this last disc is the metronome of the Marble Machine X. After putting the crank back, I could tension and tune the flat belt. Should be C sharp. La la. La la. C sharp. So in old factories they always tune the flat belts in C sharp to avoid resonances when they were listening to music, because music were almost never played in C sharp. So the flat belts didn't resonate. Here's the first beat, which means that this should be aligned with these two. Since we apparently did our lesson correct, you can see now when this is aligned with these two, the 5 screws hits the correct opening here. And inside this one, these 5 screws meet the threaded insert. Very satisfying. So, whole notes. That's so nice, that schwap. I'm gonna use this for the offbeat. Schwap, schwap. Some 16ths. Yes. Offbeat bell. Triplets. Then the offbeat doesn't make sense. Okay, you and me are going to have so much fun together. The temporary volume levers needs to stay exactly in the spot where I leave them, so I'm shimming them up with some masking tape to get them a little bit stuck in the plywood groove so they stay wherever I put them. Here I'm making the temporary sound sources. This will be built from plywood later with the real design. And these will be mic'd with contact microphones so we can isolate the sound from each rhythm disc. I attached the Allen triangular contact microphones to the temporary levers, and I'm connecting them through 4 preamps onto 4 channels in the computer, and we're getting really close to what this video is actually about, testing the timing of the mechanical rhythm machine. Okay, let's get to it. First, I wanted to sync the rhythm machine internally to make sure that the different discs hit the sound sources simultaneously. Here you can see the 3 channels that I'm recording to, and I have EQ'd the 4 on the floor a little bit like a click, and the offbeat a little bit like a hi-hat, and the 16th a little bit like a shaker, just so we can separate them. After inspecting the waveform, I saw that I needed to adjust some of the internal sync. And remember again, this is a prototype. On the real designs, we will not use this material, and we will have adjusting screws to control the internal timing. So this is how it sounds in the room acoustically. And this is how it sounds recorded. The rhythm machine is now synchronized with itself internally, and now we're going to try to sync the rhythm machine to the marble drops. I'm programming a test pattern where I'm dropping a marble every other whole note, and I'm recording the marble drop onto a 4th channel. So let's see, first try. I don't think it will sync now because I didn't adjust it yet. I'm using the computer click on 120 BPM as a guide for consistent test results, but the machine won't play exactly tight with the computer click at this stage, because we don't have the real programming plates on yet. The real programming plates are adjustable, so we can sync the crank revolution to the computer click, and the Marble Machine X will play tight with the computer, but that feature is not on yet. So the first test showed me exactly what I wanted to see. The marbles are out of sync, but they are consistently out of sync, which means that we can adjust for that. So only for this first test, I'm moving the program 1/16 earlier, so the marbles will hit earlier. This is not the real adjusting method. It's just this first test. Let's see how close we get now. When comparing the two screenshots, you can see that the marble hit have moved exactly 1/16 to the left. Here I'm putting a pencil line on the adjusting discs just to record our position on the last test. And by loosening these hex bolts, the whole rhythm machine can slide freely. The two rightmost plywood discs are securely keyed to the shaft and won't shift. And this gives us a very, very precise control over the position. First, I thought to have some kind of clutch with teeth that interacted, but then Marius helped me by simplifying this idea. He said that the friction between these plywood discs will be more than enough to keep the rhythm machine in place. So that was a great simplification by Marius. So since the marbles were a little bit late, I am delaying the timing of the rhythm machine. I'm making the rhythm machine hit later to make it sync with the marble drop. Let's test how we did. Something went wrong with the third marble drop there, but that's just because of bad prototypes. When looking closely at the correct marble drops, I could see that the marbles are still late with almost a half a 16th. So I went back to adjust the timing of the rhythm machine, and since 360 divided by 8 equals 45, which is half a 16th note, I knew I should rotate the rhythm machine 45 degrees. Let's see if that helps. So we're definitely closer, but you can see here that if we zoom in, the marbles are still 20 milliseconds late. So I'm delaying the rhythm machine a tiny bit again, and let's see how that goes. Let's zoom into that. Okay, first hit is on the millisecond. If you're used to working with audio and transients, you know that this picture means that these two sound sources are playing exactly in sync. Second hit, that's about 2 milliseconds off. That's nothing in music. Third hit is maybe 1-2 milliseconds off as well. Let's check the last hit. Absolutely spot on. This is really, really cool. Even my bad marble drop prototype is this consistent. I couldn't be happier than this. No, Martin, stop it right there. You're working on your procrastination, remember? Doesn't matter that you've been listening to Louis Cole and Wolfpack lately. This is why you're not finishing the marble machine. So we have locked in the rhythm machine towards the marbles in 120 BPM. So I'm marking 120 BPM per minute on the adjusting disc. What do you think will happen when we play in another tempo? Let's try 80 BPM. Will the marbles be early? Will the marbles be tight with the rhythm machine? Or will the marbles be late? Pick your guess. Long story short, I suddenly ran into belt tracking issues with a temporary belt tensioner. I don't like this thin, flimsy flat belt. We have already ordered a thicker V-belt. I'm going to change the pulleys anyway because I want to gear up the flywheel for more moment of inertia for tighter music from the Marble Machine X. But right now I just have to fix the issue so I can continue with the testing. This belt tensioner doesn't work, it doesn't track well, so now I'm going to eliminate that. And then I needed to remove this temporary and put this thing in instead, which meant that I lost my timing that we already made, and I have to a little bit start over from scratch. La 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 la. C sharp. So I'm back controlling that 120 BPM is tight. And we're good. So now we can again move down to 80 BPM and see what happens. So the marbles were early, exactly 1/16th early. That's because the marbles have latency. So during the delay of the marble drop, the rhythm machine is still rotating. So we have to compensate for this. And now I have to turn the rhythm machine exactly 90 degrees. Bad news is that the adjustability we have here, which is from here to here, is not enough. I need to be able to turn this more than what these slots allow. I think using 3 of these bolts is overkill. I think 1 of these bolts will be enough. Because when tightening this, there's no way this will slide out of position. So if I can just open up the slot here and bury these set screws a little bit deeper, this screw could potentially go around almost 360 degrees. Now it's only a huge project to get this off this shaft. Yeah. So here you can see the longer groove and the single bolt, and as soon as the bolt hits the wall, I can just unscrew it and move it to another hammered insert like this. By doing that, we can access the full 360 degree adjustability. And again, a control run of 120 BPM. So now 80 BPM with full adjustability of the rhythm machine, first try. The marbles were once again 1/16th early, so I placed a plier on the frame of the marble machine pointing to one of the 16th tongue. Then I could rotate the rhythm machine so the next 16th tongue meet that plier. Tighten it down and try again. He shoots, he scores. It's working, it's tight in 80 BPM. I'm delighted that this concept is functioning. Check this out. I'm alternating between 2 video frames. So in the left highlighted circle, you can see the marble hitting its hit point. And in the right lower circle, you can see the leftmost disc of the rhythm machine, the 4 on the floor disc. And you can see here that the marble and the hitter of the rhythm machine is hitting on the same frame. One frame is the 25th of a second, so I'm not so impressed by this, but it's a good visualization that the system works. Here I'm programming a beat using only 2 marble channels representing a kick drum and a snare drum. Yes. So here I'm testing the beat with the marble drops, no EQ. Both the kick marbles and the snare marbles are falling on the same plywood plate. So I'm dividing the channels inside Logic and EQing one like a kick drum and one like a snare. Here without EQ. And here with EQ. increase intensity of the offbeat by raising the lever. Here I'm having a click in my headphones, which actually makes everything much more difficult. So after some practice and a stronger flywheel, I'm sure I can play much more tight than this. It's difficult. The flywheel is not strong enough. I need a stronger flywheel to play even tighter than this. Are you ready for some 16? Activating marble beat by unmuting the vibraphone instrument group. There. So, this is a huge success. This is gonna add so much expression to the machine, and the thing is that I can program a song that goes over the whole programming wheel. It's gonna be very repetitive, right? Ga, ju, ga, ju, ga, ju, ga, ju, ga, ju, ga. Second loop. Chicka, 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 chicka. So you get this. Can you please stop? You get this progression of the music. Since this is programmed to a certain BPM, right now 120 BPM, probably this will help me lock into and keep that BPM. Everything down here is completely temporary. It's going to be beautiful levers. The things that makes the sound is going to be from plywood. We can shape the plywood to make different envelopes. So these are going to be from spring steel. So they're not bending, they can flex, but they flex back. So when they hit the top of the plywood piece, when I raise the lever up like this, it hits more of the plywood. That's going to be completely awesome. Thanks for watching. This is absolutely great.